Hi friends, in this video we are going to solve the optimization problem with inequality constraints using interior penalty function method. So first of all, in this function the constraint must be less than or equal to only we require. So that is why we will write our constraint is greater than or equal to. So we can write multiply the -1 on both sides. So we will get it as -1 minus x1 plus x2 square is less than or equal to 0. This one is minus x2 is less than or equal to 0. So our first aim is my constraint must be in the less than or equal to symbol only. I want to solve it. The first step, I want to define the barrier function. So solution, I start b of x comma rk. X comma rk is f of x. This is our objective function f of x. X is a vector value. Here x is a vector value minus rk times summation j equal to 1 to m. So here m is 2, only 2 constraints only. So logarithm of minus gj of x. This is my barrier function. So now I can write as my b of f of x is x1 minus 2 times x2 minus rk times logarithmic of minus gj. So logarithmic of minus means here become 1 plus x1 plus minus x2 square plus logarithmic of minus x2, minus of minus x2 it's become plus x2. This is my b of x comma rk. So this is the interior penalty function method. So some book they will use it as here this barrier function minus 1 over gj also. So but we are following the logarithmic barrier function, that's it. Now first step is I want to take partial with respect to x1. So dou b by dou x1 equal to 0. So that is a stationary condition. If you want to take derivative with respect to x1, 1 minus this guy is independent of x1 0. This is minus 1 over rk divided by 1 plus x1 minus x2 square. I want to take derivative with respect to x1, it's become 1. This is equal to 0. So dou b by dou x2 equal to 0 implies you want to take derivative with respect to x2. So this is independent of x2, it's 0 minus 2 minus 1 rk divided by 1 plus x1 minus x2 square times minus 2x2. So 2 times x2 plus 1 over rk by x2 equal to 0. Now you please look from this guy on implies rk equal to 1 plus x1 minus x2 the whole square, correct? So this one is coming this side. So rk equal to 1 plus x1 minus x2 square. So clearly you look, so rk equal to rk divided by 1 plus x1 minus x2 square is this guy is become 1. This is also we already know. From this implies this guy implies minus 2. So this guy 1 divided by 1 plus x1 minus x2 square is rk. So plus 2 times rk times x2 divided by rk plus rk divided by x2 equal to 0. So rk value is cancel out each other. So then you multiply the x2 is both sides. So minus 2 times x2 plus 2 times x2 square plus rk equal to 0. Now you look, so from this equation implies x1 equal to rk plus x2 square minus 1 will come. So now x2 I want to the quadratic form. So x2 square. So x2, here rk is here some constant only, correct? So x2 equal to 1 plus or minus square root of 1 plus 2 times rk divided by 2. This is the answer will come. So I simply divide by the 2. That's it. This is the x2 value. So now using our constraint, x2 is greater than 0. Correct? x2 is greater than 0. This implies here if the 1 plus, here this is more than 1. If I take the square root, this become, suppose you look only the positive quantity only will remain. The negative quantity will not be correct. So x2 equal to must be 1 plus square root of 2 plus rk divided by 2. So this is the key. Now I will know. So what about the x1? x1 equal to rk plus x2 square. So 1 plus 2 times square root of 2, 1 plus 2 rk. 1 plus 2 rk by 2 the whole square minus 1. Now you look this guy. So this is the I want to find the x1 and x2. Limit rk tends to 0. What about x1 of rk? Rk is going to 0. This guy is become 0. 0 plus 1 minus 1. So this guy is become x1 become 0. Limit rk tends to 0. x2 of rk value is rk equal to 0. x2 is this become 1. So our points are 0, 1 is the our optimal point. F of 0, 1 equal to minus 2. This is the way. So whenever we are going to numerically, we have to calculate the rk for each iteration value. Okay, that is the key. I hope you understand how to solve this problem using the interior penalty function method. Thank you.